All right, so now let's look at a few examples going over our explicit rules for our sequences. So just like yesterday, we're going to work on some matching. So it says match the given sequences to their corresponding rules. So if I look at this, now today we are mixing up our recursive rules and our explicit rules because now we've seen both. And so now we need to practice differentiating between the two. Now our sequences still look the same. We're still going to have to go through and identify, are they arithmetic or are they geometric? So let's go ahead and do that. So looking at this one, we're going 6 to 12, 12 to 24, and 24 to 48. Here it looks like we are multiplying by 2, which we are. Okay, so from 6 to 12, I'm multiplying by 2, 12 to 24, I'm multiplying by 2, and 24 to 48, we're multiplying by 2. Okay, so this right here is going to be geometric. The next one, we've got a decimal here. From 6 to 5.5, we're going down 1.5, or 0.5. From 0.5 to 5, we're subtracting 0.5. And 5 to 4.5, we're subtracting 0.5. So here, we are subtracting the same number. That makes that a common difference. So that's going to be arithmetic. The next one, from 6 to 12, now I could be multiplying 12, but then from 12, or multiplying by 2, but then from 12 to 18, that wouldn't make sense anymore. So we're going to say we're adding 6. Well, that was a weird looking 6. That looks more like an H. Let me fix that because it's just going to bother me. There you go. And 18 to 24, we're adding 6. So here we're adding the same constant every single time. That's a common difference, so it's going to be arithmetic as well. And then the last one, from 6 to 3, and 3 to 1.5 to 0.75, we're dividing by 2, or as we like to say, we're multiplying by 1/2. And since we're multiplying by the same number every time, that's going to be geometric. Now we can go through and identify which sequence goes with which rule. So the first one is geometric, so we know that that means it has to either be B or C, because those are the geometric sequences that we see. We need to look for one that has the common ratio of a 2. Since that's what we're multiplying by, well, this one has 1/2, and then letter C has the common ratio of a 2. So that's going to be C. The next one that we have is an arithmetic. Okay, and we are subtracting 0.5 every time, or we could say we're subtracting 1/2. So we need to find the arithmetic, so it's either going to be A or D, where we are subtracting 1/2 each time. Well, that's going to be D. The next one is arithmetic, where we're adding 6. Well, the other arithmetic one that we had was, in fact, adding 6. That was our common difference. Nope, don't write 6, write A. And then the last one was geometric. Well, the only other geometric one we had was B. Okay, and for that one, we needed the common ratio to be 1/2, and it, in fact, was 1/2. All right, so I want you to go ahead and try example number 2 on your own, and then you can check your work with mine when you're finished. All right, so I hope you took the time to try that one on your own. Looking at our first sequence, we have 12 to 15, 15 to 18, and 18 to 21. We are adding 3 each time. Since we are adding 3, we know it has to be arithmetic. So we look at our options. We've got arithmetic is A and B, but the only one with a common difference of 3 is B, because that common difference is right there. So this is going to be B. The next one, from 12 to 6, 6 to 3, and 3 to 1.5, we are multiplying by 1/2. So we know that this one needs to be geometric. So that's going to be C or D. Well, the only one that has a common ratio of 1/2 is going to be C. The other one has a common ratio of a 3. So on the next one, we've got 12 to 36, 36 to 108, 108 to 324. This one we are multiplying by 3. Okay, so that is going to be D, where our common ratio was multiplying by 3. And then the very last one, we've got 12 to 11.5, 11 to 10.5. We are subtracting 1/2 as our common difference. So if we look at letter A, that's where we see that minus 1/2. That's our common difference, so this last one's going to be A. All right. If you still have questions over those sequences, please make sure you're letting me know. Our next example that we've got is example number 3. It says evaluate the function f of x equals 3 to the x power minus 4 at x is equal to 3. So we're going to take that 3 and we know we need to substitute it in for the x. So instead of 3 to the x power, now we have f of 3 is equal to 3 cubed minus 4. Well, 3 cubed is the same as 3 times 3 times 3, so 27 minus 4. And 27 minus 4 gives us 23. So f of 3 is in fact 23. You also can write this as a coordinate point as 3, 23. Okay, and that's going to be our input and our output. All right, if you have any questions about those, please let me know. If not, you can move on to your assignment for the day.